Hello everyone, I am Snigdha Kakkad and this is my channel Accelerate AI Careers. Today we are going to solve a very interesting LeetCode problem, Leetcode54, spiral matrix. This is one of the favorite questions for several companies for their interview rounds. Amazon, Meta, Microsoft, Google and Salesforce have asked this question in last 6 to 12 months. So I suggest you to do this question at least 2 times to understand the algorithm behind it and how to code it. And if you have doubts, ask in the comments here. I will walk you through the question first. Then we will look at various ways to solve this question and finally we'll do the coding part. So let's get started. So what does the question say? The question says that you have been given an m by n matrix and you have to return all the elements of the matrix in spiral order. What do you mean by spiral order? Let's look at an example here. So we have been given a 3 by 3 matrix. So your m is also 3, n is also 3 here, like it is shown here in the example. And your input matrix is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And you have to return it in spiral order. As you can see by arrows here, that's your spiral order. So it's essentially your output would be 1, 2, 3, then 6, 9, 8, 7, 4, 5. So that's your spiral order as you can see here. So basically you start from the top left and you go till you hit the right boundary and you enter all the elements there. After you have hit the right boundary, you go to the bottom boundary and you enter all the elements of the rightmost column. After you have hit the bottom boundary, you take a left turn and you take all the elements until you hit the leftmost boundary. Once you have hit the leftmost boundary, then you take a turn and you go till your top boundary because you have already covered this top, so you go to your new top. And finally, once you have hit your new top, you again take a left turn and start covering in the same manner. The matrix could be say 4 by 5, 5 by 4, it doesn't matter, but your approach will be the same. Let's look at another example. So here you have been given a 3 by 4 matrix. The elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how do you go ahead with it? So again, for this also you will have a left boundary, a right boundary, a top boundary and a bottom boundary. You start with the top left and you go in the right direction until you hit the right boundary. Once you have hit the right boundary and you have pasted all the elements in the output or appended them in the output, after that you take the turn towards bottom and you start going towards bottom. And once you have hit the bottom boundary and you have appended all the elements to the result, you take a left turn and then you go towards the leftmost boundary until you hit the boundary. And you cover all the elements and append them to the result. Then you take a turn towards top and your new top would be here because you have already covered the topmost row. And you go till that top. Once you hit the top, you take a turn again towards left. And if you notice, after taking a turn towards left, the approach begins again. So you go from your new top left again to the right, then you hit the right. After that, if you have any more elements remaining, you go towards bottom and so on, right? And when do you stop? You stop when you have covered all the elements. The algorithm behind it, we'll look into it, but I hope you understand the question. So there are a few constraints they have mentioned. So your m is your matrix length, n is your matrix column length, m and n should be always between 1 to 10, and matrix I, j, the values within the matrix will always be between minus 100 to 100. I don't think these constraints impact our solution, but it's good to know about these constraints. Now we'll look at the ways we can solve this problem. Now here is my example 2 from the question. I was given 3 by 4 matrix. So I have brought this matrix here. And I'll explain you the approach we are going to take to solve this question. So I have put my top pointer here in the first row, like 0th index. I have put my left pointer here in 0th index again. So my top left is in 0 by 0 cell, right? My right pointer is not in the last cell, but a cell beside it. So it's not in the 3rd index, but it's in the 4th index. Similar way, my bottom boundary is not in my 2nd index, but it is in the 3rd index. I have done this for the sake of simplicity of code. You will understand it when we start coding. But for now, understand that whatever is our last rowth index, I have taken bottom boundary, just adding 1 to it. And what is my last column index? I have taken my right boundary just next to it, like adding 1 to it, okay? After that, we start from our top left cell. Our top left cell here is 1. So I'll first write 1 here. So whenever we start from top left, we always take a direction towards right, okay? So we go towards right, we cover the next elements. So we cover 2, then 3, and then 4 until we hit the right boundary. So once I have hit the right boundary, that is I have reached the maximum right, after that I cannot go beyond that. So I take a turn towards bottom, okay? As I explained in the example. But before doing that, if you see, we have covered this entire thing, right? So we don't need it anymore. We'll change our top, and our top will change to top plus 1. So our top will come to this cell now. That is first index instead of this cell. Okay. So basically our rectangle will become this rectangle now, which will have indices 1 and 2 in the rows, not the 0th row, because we have covered the 0th row. So our new rectangle boundaries would be this, and our top will come here. So I will strike this top here and I'll bring this top here. Okay. So that's the first thing. So when we have covered the topmost row, after that we change the top boundary. After that, I take the turn towards the bottom row and I'll cover these elements 8 and 12. Once I've hit the bottom and there is nothing more to cover, I have to take a left turn. But before taking a left turn, if you see, we have covered the entire rightmost column and we don't need that anymore. So we can move our right boundary by 1 cell and we can bring the right boundary here, as the same thing which we did with the top. So we will basically decrement right by 1. Okay. Now we have taken the left turn and we will cover 11, 10, 9 until we hit our leftmost boundary. Once we hit our leftmost boundary, we'll take a top turn. So we'll turn towards the top. But before doing that, if you see, we don't need our bottom row anymore since we have covered all of it. So we can move our bottom pointer by 1. That is, we can reduce it by 1. As we did with the right pointer, same way. Now we have taken a top turn. After that, we will go towards top. So there's only one element to be covered towards top, which is 5, because our new top is here. Once we hit the top boundary, after that, we have to cover only these 2 elements, right? So we'll turn towards left again, and 6 and 7. Now, before doing anything, if you remember, when we moved from top left towards right, after that, we moved our top to the next index. So if I try moving the top to the next index, so now my top index and bottom index are in the same cell. So when this happens, either your left index or your left boundary is equal to right boundary in the same cell, or it is, crossing it, or your top boundary is crossing your bottom boundary. That is the time to stop. That means you have covered all the elements and your spiral order has been appended to the result. You can return the result. So this is our entire approach we are going to take to solve this question. The time complexity for this would be O of m cross n, where m is your number of rows, n is your number of columns, because you're spanning through the entire matrix at least once. So that is your time complexity. Your space complexity would be O of 1, because you're not using any additional memory. So I hope the algorithm is clear. If not, I suggest you go through that algorithm explanation part once more, or once we start coding, you will get more clarity on it. If you still have any doubts, mention your specific doubts in the comments. I'll be happy to address it. So let's get to the coding part. It's very interesting, I promise you that. And if you will get stuck somewhere, you can ask. So let's get started. We first initialize our result array, where we are going to append our spiral order, which we are going to return as the result later on. So we first do that. Then we initialize our left and right boundaries. Our left boundary will get initialized at 0th index, whereas our right boundary will get initialized at matrix 0. That is the length of the entire matrix. In Python, it always works as length minus 1. That's why I have taken length of matrix, because as I told you, the right boundary should be 1 cell plus your rightmost column. That's what we are doing here. Your top and bottom boundary will also be taken the same way, 0 and length of matrix, because we want to take it 1 cell beyond the bottommost row. We will loop it until left crosses right and top crosses bottom. Either of these, if this condition is not true, if left is not less than right or top is not less than bottom, you have to stop, because that is the time you have covered all the elements. And hence I have taken both the conditions with an AND. Now I will first get each element I in the top row, okay? Because that is the first thing you cover, going from top left to the right, okay? So I start with for I in range left to right, because you go essentially from left to right. What do you cover? You append it in the result and matrix. And what would be the indices? You will cover top row and you will cover I. Okay. So once you have covered the entire topmost row, then you don't need your topmost row, right? What you are going to do after you have covered the entire topmost row, you are going to increase your top plus equal to 1. So you move your top boundary. So you get your new top. After that, you get every I in your rightmost column, right? In the rightmost column. Okay. So for that, for I in range, because now you will go from top to bottom. So that's why I'm writing this. After that, you append your result. And what would be the result? The result would be the ith row, because you're covering all the rows from top to bottom, and column would be right minus 1, because your right essentially has been taken one cell beyond the last column, rightmost column. So you are taking it as right minus 1. Finally, once you have covered the entire thing, then you change the boundaries. And which boundary will you take? You don't need the rightmost column, so you will move your right boundary. You have reached the bottom boundary, you turn towards left, so you cover all the elements in the bottom row. So get every I in the bottom row for I in range. And what would be your range? Your range would be right minus 1, because you have brought right here. Right minus 1, and you will cover till left minus 1, and you will keep on decrementing, right? Because you are going in the left direction, not in the right direction. So essentially reducing by minus 1, okay? And what are you going to append to the result? So you're going to append matrix, and the append would be bottom row, bottom minus 1, because your bottom is beyond your last row. So that's why bottom minus 1 and I, okay? I hope you understand this. After that, we'll again update our bottom index, because we don't need the bottom row anymore. So we will reduce it by 1, same as what we did with the rightmost column. So now we'll get finally every element in the leftmost column. To do that, we'll run another loop for I in range from bottom minus 1 to top minus 1. And what will we append to the result? Result dot append matrix I matrix, because we are covering all the rows, and left, because we are covering essentially the leftmost column, okay? And finally, we will change the left, because we have essentially covered the leftmost column, so we don't need it. So we will increment by 1. So if you see our approach, we increment top and left. So for top, we increment because we want to move from this to this cell next, and for left we increment so that we can move from this to this cell, as I have explained in my algorithm. And for right, once you have covered the rightmost column, you don't need it, right? So you move your right boundary, you reduce it by 1. Same for your bottom. Once you have covered the bottom row, you don't need it, so you move essentially from bottom to bottom minus 1. So you decrement it. So you should always remember which ones you need to increment and which ones you need to decrement. That's very important. Now everything else is done. We just need to return the result. So essentially return result, and I can run. I am not putting minus 1 step here. So I have to put minus 1 step here because I'm going in the reverse direction, right? I'm going from bottom to top. So I didn't put minus 1 step here. So it was taking 1 step. Let me run it again. No, there's some more mistake. I didn't take care of one condition. So what happens if I have just single row given, just one row, or I have been given just one column? What happens then? Then again, this will keep on repeating the elements, and it will repeat more than once. So you can run it through an example. Just take a one row or one column matrix and check for that. You will get wrong answers for this. So to handle that condition, you have to put a break condition here. If not, left is less than right and top is less than bottom. So in case any of the boundaries have already crossed after you have made one turn towards right or one turn towards bottom, that is either you have a single row or you have a single column. In that case, you have to break. So I think now it will work. So it's accepted. Let's submit. So as you see, the solution has quite good accuracy. The time complexity is O of m cross n, where m is your number of rows, n is your number of columns, and your space complexity is O of 1. This is your entire question. I can summarize it for you. So we first initialize our result variable. We initialize our left and right boundaries and top and bottom boundaries. And we will initialize right and bottom boundaries as 1 plus the rightmost column and 1 plus the bottommost row. So I say that's why I have not put length of matrix minus 1. I have put length of matrix. Okay. Now I will run a while loop until left is less than right and top is less than bottom. That is, your cells don't cross, your boundaries don't cross. And then I will cover all the elements first in the topmost row, which I will range from for I in range left to right. I'll append all those elements to my result. After I have covered it, I don't need the topmost row anymore, so I will increment the topmost index, top boundary. Now I'll cover all the elements in the rightmost column. So to do that, I'll go from top row to bottom row, and I'll append all of them to our matrix and results.append matrix, and I will be using I rows and right minus 1 column, because my right boundary is rightmost column plus 1. So I have to use right minus 1 here. And I decrement right after I have covered the entire rightmost column because I don't need it anymore. I have additional condition which I have to use to check for if the matrix was a single row or a single column, then I have covered all the elements. So I have to exit. So this is my exit condition. After that, I cover all the elements which are there in the bottommost row. So I essentially am going from the rightmost boundary to the leftmost boundary in bottom row. That's why I'm using a decrement step of 1. After covering all those elements, I reduce my bottom by 1 because I don't need the bottommost row anymore. Now I will go towards top and I'll cover all the elements till my new top. That's what I'm doing, going from bottom minus 1 to top minus 1. And since I'm going reverse, I have to use minus 1 as the step, and I append all the result. And finally, I will have to increment my left boundary by 1 because I don't need my leftmost column anymore. Once I have done this, my entire spiral order will get appended and I can return the result. If you like my way of solving the problems, subscribe to my channel Accelerate AI Careers if you want the notification for your daily LeetCode challenge. If there is any better approach you have to solve the question, mention in the comments. Thank you.